Now we turn our focus and we would like to know how methods can deal with arrays. We will look at this issue from three perspectives. First, how methods pass index variables or elements as parameters. Second, how methods can pass an entire array as argument. Third, how methods can retain an entire array. So let us discuss the first issue. In the first issue, we would like to know how methods can deal with array elements, index variables, when they are passed as parameters. An index variable of an array, such as this example, array I, can be used as an argument anywhere that a variable of the array's base type can be used. What does that mean? It means if you have an argument of a method, let's say for example it is defined as integer. Then if you have an array of integers, then you can pass a single element of that array to this parameter because both of them are defined as integer. Here is an example. Suppose we have a definition for a method that returns Boolean and the name is a prime and the input parameter is integer called num. So this is the method definition. And by the way, the definition for arguments is called formal parameters. So num is in fact a formal parameter. Now if you want to call this method using single elements of an array or indexed variable, all what you have to do, just supply this index variable as a parameter. For example, this is the third, in fact this is the fourth element because we start from 0. So all what you say is that you write the name of the array followed by the index. So the system will deal with it as an ordinary integer. So it will pass the value of number 3 as a copy and will copy it into num. And the parameters that we supply when we call the method are called actual parameters. So here integer num is formal parameter and number between bracket 3 is an actual parameter. Just remember that when you pass an array element or index variable as a parameter to a method as an actual parameter, make sure that the formal parameter has the same base type. Otherwise, you will get syntax error. So the formal parameter of the method is defined as integer. So therefore, if you want to pass an element to this method, it must be an integer. So therefore, the declaration for this array should be an integer, otherwise you will get syntax error. Now, if the actual parameter is passed to the formal parameter num, so what happens inside the method when num is changed? And this is what we need to discuss next. When can a method change an argument that is an indexed variable? In other words, when we pass number 3 and give it to num and we change it inside, what happens to number 3? Is number 3 the index variable will change or it will keep its copy? Remember when I said that when we call the method, a copy of number 3 is given to num. So what does that mean? It means if it's a copy, then if the copy changes inside the method, then the original value will not be changed, with some exceptions which we will discuss now in a moment. So imagine that we have a method that is called doStuff, and AI is the parameter that we want to pass to it as indexed variable. To know whether the value AI as input parameter to the method will change inside the method or not, that depends on its data type. If the base type of the array A is a primitive type, such as int, double, or char, or a float, then the method doStuff receives a copy of the value of AI. What does that mean? It means if you change it inside, you are just changing the copy. And so it cannot change AI itself because AI has the original value and the input parameter has a copy. So when we change the copy, the original value will not change. In other words, when you pass index variables to any method, if you change the value of this index variable inside the array, then the corresponding index value in the array is never changed because you are just supplying a copy. In conclusion, when you pass an index variable or element of an array of a primitive data type as a parameter to a method, if the method changes this value, then the index variable or the element of the array is never changed. On the other hand, if the base type of the array is not a primitive, if it is a class-based, then how the method receives an index variable of this array. Remember that when you declare an array of objects, we are not creating objects for each element of this array. We are creating references to objects. Later, we have to create objects and assign their references to the array elements. Now, if we want to pass one of these elements to a method, so in fact, we are passing a reference to an object. We are not passing an object. And this is what happens usually when we pass a reference to a method. We are not actually passing the object. So if the base type of the array A is a class, the method doStuff will receive a reference to AI. So if we assume that AI is the input parameter, in the first case, we assume that it was primitive. Now, what if it's a class-based? That means it is a pointer to an object. We are not passing the object. We are passing the reference of this object. Thus, we can change the state of this object inside the method. When we say change the state of the object, it means we can change its data by calling set methods, for example. However, we cannot make this pointer points to another object, because when we pass this reference to the method, if the method changes the reference, still the original reference of the array is there, so still pointing to the same object. But if you change the data inside that's pointed by AI, then you are changing the state of the object. We will show you this by an example for the two cases. If we are passing a primitive data type and if we are passing a reference to an object. As a concrete example, suppose A is an array of a class employee, and you remember that class employee consists of ID, salary, and name. Imagine that we have created an object of employee class and AI is pointing to this object. So what do we have inside AI? We have the address of this object. Let us give it an example. If this address is equal to number 5. Now when you pass AI to the method, then the method will not receive the object. It will receive the address, the reference, which is number 5. And when this method receives 5, it means it is receiving the reference of the object. So it can use this number as an address 5 to access the employee data. So it can change the ID, salary, and name of the employee by calling its set method. Now what if this method changes this reference to another number? Still the original reference in AI will not change. Still in AI will have number 5, even if you change the reference inside the method. So therefore, when the method receives a reference, it can change the state of the object pointed by this reference. However, it cannot change the original address or the original reference that is in the index variable AI. We will see this by an example in the next slide. So let us go to that example to show you both cases. What if we are passing primitive data type, and what if we are passing a reference or a class-based type? In this example, we have a class that has only one method that is called doStuff. It has two input parameters. One is a primitive, which is called A. The other one is a class-based, which is called C. Remember the definition for circle. It has a radius inside data member, and also it has setters and getters for this radius. What does this method do? It simply increments A and simply accesses the object pointed by C and changing the radius of the circle. To show you how this method is called with such parameters, we have written a demo class that consists of only main method. In the first line, we are creating an array of integers of size 3. The name of the array is number. It is initialized to the constants 3, 4, and 5. This is how we visualize the array inside the memory. At index 0, we have the value 3. At index 1, we have the value 4. And at index 2, we have the value 5. In the next line, we are declaring an array of objects of 2 elements. These objects are of type circle. Remember that for a circle, it's a class that consists of one data member, radius, and it has getters and setters for this radius. Now, when you declare an array, none of the index variables are pointing to an object. In fact, no objects are created yet. As you notice here, you see this is the picture of the array. In fact, we are creating an empty references of size 2. So index variable 0 is pointing to null, and index variable 1 is pointing to null. No objects are created at this stage. Now, if you want to make these index variables or elements point to objects, then you have to create objects and assign their references to these index variables. And this is what's happening in the next line. In the next line, we are creating two objects. One for circle with radius 6.1 and the other one with radius 2.1. Now, when you create an object, this is how we represent objects inside the memory. Notice that the first object has radius 6.1 and the second object has radius 2.1. And since the array holds only references, so how we represent this graphically, we draw an arrow from the index variable to the object. See, notice that in index 0, we have a pointer. That means the address that is saved inside this index variable is referring to the address of this object. So graphically, we represent this by an arrow. And for the next index variable, the address that is stored in this index variable is the address of this object. So this is why we say that this index variable is pointing to this object. So this is the picture we can visualize whenever we create an object and assign its address to an index variable of an array that is declared an array of objects. Now is the time to call the method doStuff. But to show you which parameters are affected when they are changed inside the method, we need to print these arguments before we call the method, and we need to print the values of these arguments after we return back from this method. So in the next line, we are in fact printing the arguments before they are passed as parameters to the method doStuff. So what is printed? Here we are writing a message or displaying a message before. At the same time, we are displaying the value for number 0. Where is number 0? So this is the array number. At index 0, we have a 3. So in the output screen, 3 is printed. Followed by space, followed by circle 0. Where is circle 0? This is circle 0. It is pointing to an object of type circle. And we are calling the object getRadius method. So it will get us the radius of this object, which is 6.1, and 6.1 is printed on the screen. Notice here we are using circle 0, and circle 0 is an array of object of type class circle. So it is a pointer. And so how to call an object, if you know its reference, we use dot. Now next we are calling the method. After printing the values of the arguments before we pass them to the method doStuff, now is the time to call the method with the parameters number 0 and number 0. This is number 0, which is the first element of the array number, and circle 0, which is the first element of the array circle. For number, it is an array of integers, primitive data type, and circle is an array of objects. So we are passing a reference of an object. So number 0, 3 will be passed as an argument, and circle 0, an address of circle 0, which is the pointer, will be passed as a parameter. Before we proceed, we need to understand the names of the parameters. Now, when you define a method, the parameters you define in the method are called formal parameters. And when you call the method, the parameters you pass to the method are called actual parameters. So number 0, circle 0 are the actual parameters. Integer A, circle C are the formal parameters. Now when the method is called, if we have a primitive data types, so copies will be passed to the method. So in fact here we have number 0 is equal to 3. This 3 will be passed to the variable A. So when we go inside the method A, a new variable will be created and it will hold a copy 3. And for the second parameter, when we pass circle 0 as a parameter, so the reference that is pointed by circle 0, which is this arrow, will be copied into C. So C is not the object itself. C is just a pointer That means when we enter the method, the value of C will point to the same object as circle 0. So there will be two references that pointing to the same object. In other words, the data inside the object can be changed from two references. The first reference is the original index variable circle 0. The second reference will be the parameter C. Let us see what happens when we go inside the method. Now when the method is called, then two variables will be created for the input parameters. One is called A and the other one is called C. A is a primitive data type, therefore the system will pass a copy of the actual parameter. And the actual parameter is number 0, and in number 0 we have the value 3, so 3 will be copied into the local variable A. Notice that A receives a copy of the actual parameters. So in the second parameter, which is a reference to an object, it will receive the reference of that object. Where is the actual parameter for this formal parameter? We have circle 0. And what is inside circle 0? Inside circle 0, we have a reference to an object of type circle. This reference is copied to C. So that means C and the reference circle 0 are pointing to the same object. And this is why we are drawing an arrow from the variable C pointing to the object that is the same object that is pointed by circle 0. In other words, this object can be accessed from two different references. One from the index variable circle 0 when we are inside main, and the other one from the variable C when we are inside doStuff method. Now let us see what happens when we change the values of the local variables A and C. In the first line inside the method, we are increasing the value of A by 1. Remember that A receives a copy from the actual parameter number 0. So here we have a 3 and here we have a 3. But when you change the value inside the method of A, since A is a primitive data type, in fact you are changing the copy. The original actual parameter value has never changed. Why? Because we are passing a primitive data type. And this is really what happens for any method. When you pass a primitive data type, if you change the formal parameter, the actual parameter never changes. So when you come back from the call of the method, still the variable holds its original data, even though if you change its copy value inside the method with a different value. Let us see the situation when we pass a reference as an input parameter. Now C is a reference, and C is pointing to an object that is pointed by the same index variable circle 0. Now inside this method, the method can change the state of the object that C is pointing to, but it cannot change the value of circle 0 address. So see the reference that is saved inside circle 0, the method cannot reach it. It is unreachable from the variable C. But C can reach the object that is circle 0 is pointing. So therefore now, when we call C.setRadius 3.5, now C is pointing to this object. And when we call this object setRadius to 3.5, then it's going to change the radius from 6.1 into 3.5. After we return back from the method, now we need to print the values of the actual parameters in main. Notice that we have deleted the variables A and C. Why? Because the system resumed control back to main method. And you know that when we call a method, then the variables inside the method are created temporarily. After finished and returned back to the caller, those variables are destroyed and removed from the memory. So therefore A and C are now removed from the memory, but C variable, when we were inside the method, has changed the state of the object that it was pointing to. Now when we return back, we would like to see which of these actual parameters has changed. Now number 0 was passed by value because it was primitive. Now when we return back, when we printed, what do you expect the output will be? Where is number 0? This is number 0. It has the value 3, although we have changed it inside the method to 4, but that change was done inside the method. When we return back, its value is untouched. However, for circle 0 because we passed the reference of the object. So the method can see the object and can change its value. This is why when we say that when we pass a reference to an object, then it can change the state of the object, but it cannot change the address that is saved inside the array. So notice that circle 0 is still pointing to this object, but the data has changed from the method doStuff. So what will be printed for circle 0.getRadius? Circle 0 is pointing to this object, and the object radius is 3.5. So this is the output. After returning back from doStuff method, the value of number 0 has never changed. It is still 3, but the radius of the object that is pointed by circle 0 has changed to 3.5. How this change happened? It happened inside method because we passed a reference. Let us go back a few lines and let us assume we are still inside doStuff method. Let us assume specifically we are at this line. Now this line does not change the value of C. In fact, it is changing the state of the object pointed by C. Now what if we try to change the value of C? What happens? If we try to create a new object of circle of radius 7.5 and assign the reference of this object into C. In other words, if we write C equal a new circle 7.5, so we are changing the value of C. Graphically, we can visualize it as follows. Since we have changed the value of C to a different object, so the arrow that was pointing to the object of radius 3.5 will change and points to the new object. So we have changed the value of C as a formal parameter, but the actual parameter that was passed to C, which was saved into circle 0, has never changed. Still, circle 0 as an index variable is pointing to the original object. But when we assigned its address to a parameter of a method, then the parameter can be used to access the object but cannot change the address that was saved into the array. And this is why when we say that when you pass a reference of an index variable to a method, the method can change the state of the object pointed by this parameter, but it cannot change the reference that was in the actual parameter. And this completes the discussion that whenever we pass a primitive data type to a method, if you changed the formal parameter of that value, its actual parameter never changes. But if you pass a reference to a method, then the method can change the state of the object that is pointed by this reference.